This is Precalculus section 2.1 notes. Welcome to chapter 2, where we are going to be spending a lot of time talking about functions. So first, a function is a rule where every member of the input, and another word for input is domain, has exactly one member of the output. And another word for output is range. So we're going to be talking a lot about domain and range in this chapter. We have a few examples here to begin where we have this polynomial f of x and we're supposed to evaluate the function at the given values. So for number 1, f of 7 just means take the function f and wherever you see the variable x, you plug in 7. So f of 7 is going to be equal to 7 squared plus 3 times 7. And then we just have to follow PEMDAS. 7 squared is 49, 3 times 7 is 21, and 49 plus 21 gives us 70. So f of 7 equals 70. For number 2, f of negative a is going to be equal to negative a squared plus 3 times negative a. Well, even though we don't know what a is, we know it's negative, but when you square a negative, you always get a positive. So this is going to become a squared. 3 times negative a will give us negative 3a. And that's the best we can do without having a value for a. Example number 3, f of m minus 5 is going to be equal to the quantity m minus 5 squared plus 3 times the quantity m minus 5. Now be careful here. That squared means we have to do a FOIL. That's not a sprinkle, remember. Think of the poster on my classroom wall. You can't sprinkle over a sum or a difference. This is a FOIL. So this is going to be m minus 5 times m minus 5 plus, and then I'm going to go ahead and distribute the 3m minus 15. When I FOIL the m minus 5s, I get m squared minus 10m plus 25 plus 3m minus 15. And then finally, combining like terms, we have one m squared term. Our m terms are negative 10 and positive 3. That's going to give us a negative 7m. And our constants are positive 25 and negative 15. So that's going to give us a positive 10. And that is f of m minus 5. And the next example is a piecewise function. Maybe it's been a while since you've seen one of these. Everybody loves these in Algebra 2. So a piecewise function is just multiple functions that appear on the graph at the same time, but they only live in a certain place. So on the left-hand side here, we see the function. And on the right-hand side, this is what I would call where it lives, or its domain. Okay, so that's going to help us figure this out. So whenever we're doing this, we're always selecting the right piece of the function to answer each question. So number 1, f of negative 14. Where does negative 14 live? Is negative 14 less than 2, or is negative 14 greater than or equal to 2? It's less than 2, right? Negative 14 is less than 2, so we're going to use f of x equals 3x. So f of negative 14 is going to be equal to 3 times negative 14, which gives us negative 42. In example number 2, we're looking at 82. Where does 82 live? 82 is greater than or equal to 2, which tells us that we are going to use the function x minus 2 squared. So f of 82 is going to be equal to 82 minus 2 squared, which is going to be equal to 80 squared, which is equal to 6,400. And then the third example here, f of 2, be careful with this one. 2 is greater than or equal to 2. 2 is not less than 2. Since 2 is greater than or equal to 2, we will use the x minus 2 squared function. So we're going to do f of 2 equals 2 minus 2 squared, but 2 minus 2 is 0, right? So 0 squared is 0. In the next set of examples, it says use the function to evaluate the given expressions. So we have f of x. They're asking us to do f of x over 4 and f of x divided by 4. Please note that these are not the same. F of x over 4 means that we are plugging in x over 4 for the variable in the expression. So f of x over 4 is going to be equal to 8 times x over 4 squared plus 24 times x over 4. And then I can go ahead and I can simplify that. So that's going to be equal to, I have to sprinkle my exponent here, 8 times x squared over 4 squared plus 24x over 4, which both of these, of course, can be simplified because 8 squared is 16, or sorry, 4 squared is 16. So 8 over 16 is going to be equal to 1 over 2. So our first term is x squared over 2. And our second term, 24x divided by 4, is going to be equal to 6x. So final answer, x squared over 2 plus 6x. The second example asks us to do f of x divided by 4. Well, that just means take the function, which is 8x squared plus 24x, and put it all over a 4. So this is what I call, let me change my color so you can see it here. This is what I call a love connection, right? Because we're going to divide both of these by 4. See the love there? So this is going to give us 8x squared over 4 plus 24x over 4. We can go ahead and reduce. 8x squared over 4 is 2x squared, and 24x over 4 is 6x. So that one ends up being 2x squared plus 6x. The next examples introduce domain of a function. We've got a little vocab. Domain is the set of all of the inputs of the function. These are the values that we're plugging in. Typically, these are our x values. It can be expressed explicitly. And what that means is that it's given in the problem, like they tell you what the domain is. For example, they might say that your function is f of x equals x squared, and then the domain part would say for 0 less than or equal to x less than or equal to 5. So that tells you that all your x values lie between 0 and 5 and include 0 and 5. So that would be your domain. If it's not expressed explicitly, then the domain is going to be all real. So keep that in mind. If they don't give you a domain, then you assume the domain is all reals. So you could either write that as x equals all reals, or you could write it as an interval, right? And you could say negative infinity, comma, positive infinity, because both of those are a way to express all reals. Our next examples ask us to find the domain of the function and express the answer in multiple ways. And again, a reminder here, our hint. Domain means what are we allowed to put in for x? What can we put in for x? So for example number 1, this is a polynomial. So all values of x will work. Our domain here is going to be x equals all reals. In set builder notation, we would write that as x such that negative infinity is less than x, which is less than positive infinity. Or in interval notation, we would write that as negative infinity, comma, positive infinity. Make sure you've got those round brackets on that one. Our second example, the function is f of x, and then we're given a domain in interval notation, right? So this tells us that x is between 2 and 10, but bigger than 2 could be equal to 10. So our domain here is x is greater than 2 and x is less than or equal to 10. In set builder notation, that's pretty much going to look just like how it was given. X such that 2 is less than x, which is less than or equal to 10. And then our domain in interval notation would be a round bracket on the 2, comma, a closed bracket on the 10. Example number 3, f of x equals 1 over x squared plus 7. In this case, we do have to think about our domain because the two things that give us domain restrictions are going to be anything that makes our denominator 0 and anything that gives us a possible negative value under an even root. So I'm going to take a second and I'm going to write that down because that's important information. And there is a poster with these restrictions on my classroom wall right by the clock. So our domain restrictions, it's going to be anything that makes the denominator equal 0. And the other thing is anything that makes a negative number under an even root. Okay, so those are the two things that we need to be concerned about when we're thinking about domain. We did not have either of those issues with example 1 or example 2. But now with example 3, it's possible that we might have an issue because we've got a variable in the denominator. So basically what this is saying is that we have to keep x squared plus 7 greater than 0, right? It can't, I shouldn't say greater than 0, can't equal 0. It could be negative. So we're going to say x squared plus 7 cannot equal 0. So if I go ahead and I do some algebra here, that just tells me, if I were to get x squared alone, right, that x squared can't equal negative 7. But if I square root that, I get no solution, right? Because that tells me that x cannot equal plus or minus the square root of negative 7. Well, the square root of negative 7 is imaginary, right? So what this tells me is I could plug any real number in for x because I'm squaring it in the function, in the denominator, and even if x is a negative value, when I square it, I'm going to get a positive number no matter what. Then I'm always adding 7 to it. So no matter what value you plug in for x, you're always going to end up with a non-zero value in your denominator. So this tells us that for this particular function, our domain is x equals all reals. In set builder notation, we could say x such that x equals all reals, or we could say x such that negative infinity is less than x is less than positive infinity. And our domain and interval notation would be negative infinity, positive infinity with rounded brackets. All right, last example. We've got f of x equals the square root of x plus 5. Keep in mind, one of our domain restrictions is anything that makes a negative number under an even root. And that is the case with this problem that we have to be careful of. So that tells us that x plus 5, which is under a square root, that's an even root, that tells us that x plus 5, we have to keep it greater than or equal to 0. We can't let x plus 5 become a negative number. So if we get x alone here, just do this little algebra, what we discover is that we have to keep our x values greater than or equal to negative 5 if we want to keep what's under our root greater than or equal to 0. We just found our domain. So our domain is x has to be greater than or equal to negative 5. In set builder notation, x such that x is greater than or equal to negative 5. And in interval notation, square bracket on negative 5, comma, round bracket on infinity.